In this lesson, we're going to learn about subsets. A subset, if you talk about a subset is a set A. Set A is a subset of set B. Just to kind of talk about it. So set A is a subset of set B if and only if all the elements or every element which is part of set A is also a part of set B. Okay, so whatever is in set A is also a part of set B. And the symbol that's used is like the sideways U and the line under that. So A is a subset of B. It's written as A sideways U with a line or line segment under that. Let's learn a little bit more about subset relationships. So every set is a subset of itself. So intuitively, A is a subset of A. The second relationship here is a null set, which is an empty set, is a subset of every set. So a null set is a subset of every set. Let's see some examples here. The first one you're seeing is it's asking you determine whether each of the statements that's given to you is true or false. All right, the first one. So you have a set 5, 10, 15, 20, and it's asking you, is that set a subset of 0, 5, 10, 15, 20, 25, 30 or not? And the answer is yes, right? Because you see all this, the numbers, the first set are also in the second set. Second one is set of whole numbers is a subset of natural numbers. That's false, right? Because whole numbers has an extra 0, which does not belong to the counting numbers or the natural numbers. Because the counting number starts from 1, whole numbers start from 0. So you have a set 1, 2, 3, and it's asking you, is it a subset of itself, 1, 2, 3? And the answer intuitively is, it's true, right? And the last but not the least, you have empty set. Is that a subset of every set? And that's what we learned before. Empty set is a subset of every set. So that's true. Now let's talk about Venn diagrams. So Venn diagram is a diagram like this. It has a rectangle. So the rectangle is the universal set, and the circle inside is the set that we are referring to. And the outside the circle part, inside the rectangle, that part, the empty part, is the complement of set A or A prime. So use a universal set at that very context, right? A is the given set, whatever is given to you. and then A prime is a complement, right? So now we're going to talk about what's a proper subset. So a proper subset of a set A, or set A is a proper subset of set B, if all the elements of set A are in set B. So that's the meaning of a proper subset. If every element of set A is also in set B. And A and B are not equal to each other. So the equal part is not there. So let's see an example here. So you have A, E, I, O, U, the vowel set. And the question is so the given that's E, I, O, U, A, is that a proper subset? And the answer is no, because they're exactly equal. So equals do not count as a proper subset. Because if it's exactly the same, then they are equal, they're not a proper subset. So now you have natural numbers and have integers. Is the set of natural numbers subset of the set of, or a proper subset of the set of integers? Is a set of natural numbers a proper subset of a set of integers? And the answer should be a yes, right? Because natural numbers has all the positive counting numbers, right? And integers has all positive and 0 and negative, right? So, right. How do we figure out the number of subset of a given set? So a set with n elements, if you count all the subsets of set with n elements, there will be 2 raised to the n subsets. Now remember, one of them is itself. So to count the proper subset of a set with n elements, you'll have to subtract 1 from this formula. So the number of proper subsets will be number of proper subsets of a set is 2 raised to the n minus 1. Why minus 1? Because we're going to include the equal one also there. Let's see our example here. So we have 4 condiments that we use in a hot dog, right? So what do we put on hot dog? We put mustard, right? So in this question, we need to find out what is the number of proper subsets. So the hot dog stand has condiments, has mustard, and it has ketchup, and then it has onions, and last but not the least, it has relish. Those are the three toppings that I used, right? Or 4 condiments that I used. So you make a list of all the subsets. If some people just want mustard, or some people just want ketchup, or some people just want onion, so you're going to have empty set, then you have mustard set, then you have ketchup set, then you have just onions, and then you have just relish. Some people might need two toppings, so mustard and ketchup. Some people might need mustard and onions. Some people said mustard and relish. Some people might say ketchup and onions, or ketchup and relish, right? Or onions and relish. So the first one, individual ones, is 4, and these are 6. Now I'm going to put 3 of them. Mustard, you have ketchup and onions. You have mustard, ketchup, and relish. Then you have mustard, or onions and relish. And then you have mustard, then you have ketchup, onions, and relish. These are 4. And the last one will have all the toppings, so mustard, ketchup, onions, and relish. So if you count them all, that is your total number of subsets of the condiments, right? So which is how many? 1 plus 4, which is 5, plus 6 is 11, 11 plus 4 is 15, and 15 plus 1 is 16. So we counted them all, we got 16, which obviously is 2 raised to the 4, because remember the formula was 2 raised to the 4. Alright, so that's your 16, 2 raised to the total number of condiment. And then if you were to find the proper subset, so we'll have to not include the sub one which has all of them. So that will be 2 raised to the 4, 16, and then minus 1. Because remember, the last one that we have, which has everything, is not a proper subset. So we exclude that, that's going to be 15. So we're going to have 15 proper subsets of the set of condiments that can be used on hot dog. All right. So we learned subsets. We learned Venn diagram. We are learning the proper subsets. So this lesson has a combination of a lot of things, right? All right.